So today we're going to talk about arithmetic sequence. Learning target. I can illustrate arithmetic sequence. Let's have a warm up. So number one, the first given sequence is 80, 65, 50, 35, and 20. What comes next? If you look carefully, you will see that the previous number is subtracted by 15, and that is the next number. To check, 80 minus 15 is 65. Then 65 minus 15 is 50, and so on. So 20 minus 15 is 5. So letter B. Another example. So 3, 8, 13, 18, and 23. What comes next? In this, we add 5 to the previous number to get the next number. So to check, 3 plus 5 is 8, then 8 plus 5 is 13, and 23 plus 5 is 28, letter C. Were you able to find patterns and get the next number in the sequence? Let us now give the formal definition of a sequence. But before that, let us read the process questions. When is a list of numbers called a sequence? Number 2, when is a sequence finite or infinite? Number 3, in what ways can you express a sequence? Number 4, when is a sequence arithmetic? Explain. Sequence. A sequence is an ordered list of terms or elements. Here are some examples. 2, 4, 6, 8, 10, and A, E, I, O, U. Each term in the sequence is identified by its location in the sequence. A sub 1 is the first term, so in the first given sequence, which is 2, 4, 6, 8, 10, the first term is 2. So A sub 2 is the second term, so the second term is 4. A sub 3 is the third term, so the third term is 6, and so on. A sequence can be finite or infinite. When we say finite, finite sequence, as we see in our given sequence 1, 3, 5, 7, 9, there is a specific number of terms, and then it stops. So it is also called function with the domain 1, 2, 3, 4, and 5. Then range 1, 3, 5, 7, and 9. Next, infinite sequence. When we say infinite sequence, as we see in here, it continues on forever. And know it because of the dot, 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 and it is called ellipsis. So the domain is 1, 2, 3, 4, and 5. The range is 1, 3, 5, 7, and 9. A sequence often expressed as a rule or formula. Examples are a sub n is equal to 3n plus 1. Then a sub n is equal to 2 raised to n plus 1. Let us find the first three terms of each sequence. So the first formula is a sub n is equal to 3n plus 1. Since we're finding the first three terms, we have to write a sub 1, a sub 2, and a sub 3. So to find a sub 1, that means n is equal to 1. Then a sub 2, n is equal to 2. Then a sub 3, n is equal to 3. So let's simplify. 3 times 1 is 3 plus 1 is equal to 4. Next, a sub 2 is equal to 3 times 2 is 6 plus 1 is 7. Then 3 times 3 is 9 plus 1 is equal to 10. So the first three terms in this formula, a sub n is equal to 3n plus 1 is 4, 7, and 10. Next, a sub n is equal to 2 raised to n plus 1. So let's write a sub 1, a sub 2, and a sub 3. So we substitute the value of n, 1, 2, and 3. Simplify. 2 times 2 raised to 1 plus 1 is equal to 3. Then 2 raised to 2 is equal to 4 plus 1 is equal to 5. Then 2 raised to 3 is 8 plus 1 is equal to 9. So the first three terms are 3, 5, and 9. Okay, let's talk about arithmetic sequence. An arithmetic sequence is a sequence that has pattern where every term after the first term is obtained by adding a constant called the common difference. To identify the common difference, here is the formula. So D is equal to A sub n minus A sub n minus 1. So in this formula, we have to substitute the given n, which is, let's say, 2. So we substitute 2, then A sub 2 minus, substitute 2 again with n, 2 minus 1. So simplify, A sub 2 is equal minus A sub 1 is equal to, so let's identify the A sub 2 and A sub 1. So A sub 2 is 4. Then A sub 1 is 1. So 4 minus 1 is 3. Then another is, let's substitute 3. So A sub 3 is equal or minus A sub 3 minus 1. So simplify, A sub 3 minus A sub 2 is equal to 7 minus 4. So 7 is the third term and 4 is the second term. So 7 minus 4 is 3. That would be all.